Let's have a look at congruent triangles, which are, of course, triangles that are exactly the same in every aspect. In order to prove, we need three pieces of information, as you will recall. Not necessarily always, but if you're stuck, look for a side, because every single proof involves there being a matching side that's the same. So if you're unsure, maybe look for that first. So the test that we have, of course, we have our side, side, side. Oh look, here's two triangles. Oh, that side matches. So does that one. Oh, third one does too. Fantastic. Then what we do basically is we eliminate one side and replace it with an angle. So the next one, side, angle, side. So that side matches. So does that one. But of course it cannot be just any angle, and that's why we write it as side, angle, side to highlight it's got to be the angle in between the two sides that we know, which is called the included angle. Alright, let's drop off another side, replace it with an angle. So angle, angle, side. Now this time it's the two angles we identify first, because it's the side that must be in the matching position. It doesn't have to be the included one, so it doesn't have to be the side in between the two known angles. It could be the one opposite the one I've marked there in green. But it's basically got to be the same one in both, the matching or the corresponding side. There is, of course, a fourth one, which is actually the other ones anyway. Right? If you know it's a right-angled triangle, and the hypotenuses, or is that hypotenuse? Okay, so you got right angle, hypotenuse side. Let's do this very old question, 1985. We're going to prove that DA is the same as AB. So when I'm setting mine out, I like to write the piece of information down, so whether it's an angle or a side. So I've noted, okay, I've found an angle. DAS and BAS, well, they told me they were the same. AES is a side which is common to both triangles I'm playing with, and they're both right angle triangles, so I actually have angle, angle, side. So yes, they're congruent. Therefore DA is equal to AB, matching sides in congruent triangles. Now they want us to prove DC is equal to CB. Alright, well we've just proven DA is equal to AB, so I have a side. If I now look at the larger triangle, DAS and BAS, again they were the given angles, and AC is common to the two larger triangles there. So AC is common, so this time I have side, angle, side. And so again, matching sides in congruent triangles. Right. The different types of triangles, of course we have our isosceles triangles. AB is equal to AC if I wanted to use that fact. Remember, I'd need to know it's isosceles to use this fact. They're equal sides in an isosceles triangle. If I wanted to use the fact with the angles, then that would be the equal angles in the isosceles triangle. If they had not told me it was an isosceles triangle, but say they had told me the two angles were equal, I don't have to actually go and prove they're isosceles, because the other reason that I could use AB equals AC is we could say the sides opposite equal angles in a triangle are equal. Right? Because sides are always in proportion to the angles around the triangle. So if it's opposite an equal sized angle, then the side must be equal sized as well. In an equilateral triangle, all three are equal. I don't have to say equal sides in an equilateral triangle, because they're all equal. So I just say they're sides in an equilateral triangle. Similarly with an angle, and of course they're all equal to 60 degrees. Some terminology. Altitudes is another name, of course, for perpendicular height. Then we have a median. That's the line that joins the vertex up to the midpoint of the opposite side. And a right bisector. This one also goes through the midpoint in the opposite side, but won't necessarily go through the vertex. It's at right angles to the midpoint. Now, it'll go through the vertex in the isosceles triangle, but in any other triangle it won't. And of course, in every triangle, those lines, if you were to draw all three of the possibilities in, they should always be concurrent. You always go through the same. All right. 8C will do us for today.